Okay, so we are in Chapter 8 of Statistical Rethinking, second edition. We are just starting the medium hard questions, and we'll cover 8M1 as well as 8M2 here. Okay, so 8M1. So we're looking back at an example that was presented in the chapter, the tulips example, as in flowers. In that regression, we had this here. We had this regression equation, okay, where W stands for water, S stands for shade, and then there was an interaction term here. Okay, and the size of the blooms depended on this equation here. Okay, so now we're asked to imagine that there was actually another variable, which was hot temperatures. Okay, and hot temperatures, this is a binary, so it's either hot or not hot temperature. Okay, so it's not temperature as in from like 0 degrees to 100 degrees centigrade. It was either, these tulips were either grown in cold weather or cold temperatures or hot temperatures. Okay. And when we did that, the flowers that were grown in hot temperatures never developed any blooms. Okay, so we want to explain this in terms of interactions between water, shade, and temperature. So I feel like wording this answer is a little bit awkward, but you can kind of see my answer right here. So basically, there is some sort of interaction with heat and these other variables, right? Because the effect of water, the effect of shade, and then the interaction between them all apparently depend on heat, right? So heat is interacting with each one of these variables, and even actually the intercept here, right? I think later we'll figure out that we can actually have a different intercept for both hot temperatures and cold temperatures, or whatever is applicable to the particular problem. Okay, so for number 2 is we want to invent a regression equation that will guarantee to make bloom size 0 whenever temperature is hot. Okay, so this really tests, I guess, your understanding of I guess, just a basic linear equation. I don't know that you would ever try to make this type of regression in practice, because you are assuming, you are making a very big assumption, which is that heat always causes no blooms to occur, or for their size to always be 0. And I don't know if that's an assumption that you would want to make in this particular experiment, but nevertheless. Okay, so what we might think that the regression would look like would be to expand the existing equation, right? So by adding a heat term, and then a heat by water interaction, a heat by shade interaction, and then a three-way interaction. I think that would be the gut answer, the gut response to answering this question. But that wouldn't really be correct here, because we're trying to guarantee that bloom size would be 0 when temperature is hot. Okay. Well, if we do what I've written down here, the only terms that can go to 0 are, because of heat, are the ones where heat is a variable, right? So this term, this term, this term, this term. But that still leaves, well, it still leaves exactly these problems, right? I'm sorry, these terms that do not have heat. And so these could produce a non-zero value for mu. Okay? So I think what we want to do instead, so earlier I was saying that apparently heat interacts with all of these things, right, is we would set up an equation like this. So here we have the original equation, and then something like this, right? So imagine what's happening here. So if heat is binary, so it's either 1 or 0, 1 means heat, okay? Well, then if there is heat, right, if the plants are grown in a hot environment, then this is 1 minus 1. That means 0. That means that the whole thing becomes 0 and there's no bloom size, and that's what we're supposed to do. If there is no heat, well, then this becomes 0, so this whole term becomes 1, which is just the original regression, where the plants are grown without heat. Okay, that's it for this.